All right, good day, students. Today what we're going to learn about is how to create a Bohr-Rutherford model of the atom. Now, the Bohr-Rutherford model, that stands for two scientists, a guy by the name of Niels Bohr and Ernest Rutherford, and they did a series of experiments to say that an atom is made up of basically three subatomic particles. What are those particles? You know this already. Those subatomic particles are the protons, the electrons, and the neutrons. And this is sort of a model of it. This is sort of a Bohr-Rutherford in the center of your atom in here. What are these guys in the center? Those are the protons, and they're in the nucleus. Okay, and in there are the neutrons as well. And we have protons in there. And this is a terrible diagram because in reality, the nucleus is so incredibly small. Okay, if you actually were going to draw on an atom, the protons would be so tiny, and the electrons actually take up most of the space, and they're even smaller, but they're flying around at the speed of light in these orbits. Okay, and so this is what an atom looks like. The nucleus is small, all the mass is here. You got protons and neutrons, and you have electrons flying around. So question, why don't those electrons fly away? Well, the answer is that the electrons have a negative charge, and in here you have a positive charge, and positive things like negative things, so it doesn't fly away. So you have the shells and so on. So the electrons orbit that nucleus. And remember, the first shell holds 2, the next shells hold 8, and so on. Okay, so like I just said, the rules for making these Bohr-Rutherfords, which we're going to make, is we have to show all the protons, electrons, and neutrons. And if we're going to place the electrons, we have to place them in orbits or shells. The first shell can hold 2, the next shell can hold 8, and the third shell can hold 8 as well. So if we're going to draw it, what we want to do is we want to show nitrogen. Okay, it's an example here. So what we do is we look on the periodic table and we see that there is 2 numbers for nitrogen. There's the atomic number of 7, and that means that if we have a 7 here, that means we have 7 protons. Okay, and it also means you have 7 electrons when it is neutral. So the positive charge has to equal the negative charge. Electrons are negative, protons are positive. Protons are in the center and electrons are flying around on the outside. We are not going to worry about neutrons quite yet. Let's just draw our diagram. So what we do is the first shell holds 2 electrons, so we half fill that first shell. So I'm going to fill up that shell right now with 1 electrons. 2 electrons. That next electron actually has to go right beside it right there. That's okay. Okay, so I actually have 2. I don't know why I drew that line there, but you have 2 electrons in the first shell. Okay, how many more electrons do we have to place? Well, the answer is 5. Now we have to place 5 because we had 7 electrons. So I'm going to place 5 around the next shell, but you'll notice that I'm not going to pair them. Why didn't I do that? Well, this next shell holds 8. So that means you have 4 positions at north, east, south, west, and then you can pair. And now, once we're half full, we are in the process of pairing. That's 5. If we count up our electrons, this is 7 electrons. If we look at this compound here has something that has 5 valence electrons. And I'm going to use an E negative to represent electrons. 5 valence electrons, that means electrons in the outer shell. Okay, that's 5 valence electrons. So what are we missing? So far we've just shown the protons and just the electrons. We haven't shown the protons and neutrons. Where are they located? Well, I don't know why I did that there, but the protons are located in there, and so are the neutrons. So if we look at this, I want you to remind you again, the electrons, they don't weigh anything. These have a negative charge, but they don't weigh anything. So these 7 electrons, they don't weigh anything. All the mass is located in the nucleus. And the P in the end, that's nucleus. And the P in the end, that represents where they are. They're protons and neutrons in the nucleus. Okay, so here we have our Bohr-Rutherford diagram for nitrogen again. But what are we missing? Well, we have our electrons on the outside, and you can see that we have 7 of them. What we haven't figured out is how many neutrons we have. How do we figure out how many neutrons we have? We remember that nitrogen, when we looked at the periodic table, it had two numbers. It has a small number, which is known as the atomic number, which is the number of protons, and it's equal to the number of electrons when it's neutral. There's also a big number on the periodic table that says 14.01, and this number actually comes from, it's the mass, it's the atomic mass. So if I asked you what subatomic particles actually contribute to the mass, you should say protons and neutrons. Electrons have no mass, okay? So if electrons have no mass, and we have 7 protons, that means the protons are contributing a mass of 7. So if protons plus neutrons equals 14, and we plug in 7 here, what's the number that goes for the n to make it add up to be 14? Well, the answer is 7. So there is 7 neutrons here. The diagram that I'm showing you is actually okay, but I'm going to ask you to draw them this way, to actually, instead of putting the n, you're going to put P 7 N 7. So 7 protons, 7 neutrons. And if we look around, we're just going to draw it the exact same way. I'm going to put my electrons around. And notice how I place them. Half fill. And then we pair. How many valence electrons does this have? Valence electrons are the electrons in the outermost shell. This has 5 valence electrons. I hate that. Sorry, guys. Okay, so let's try one more. I'm going to look at the periodic table, but now we're going to look at, I'm going to zoom in to calcium here. Calcium is actually the hardest one to do. It says Ca right there. It's got two numbers, 20 and 40.08. We're going to use both those numbers. Now, I want you to remember that we can't do any elements past calcium. We actually stop at calcium. It's the last one that we can do. So all the other elements past 20 we can't do. So we can do Bohr-Rutherfords for 1 to 20, and then the model doesn't work anymore. Alright, so calcium had two numbers there. Ca had 20 and it had 40.08. What I'm going to do is I'm just going to get rid of this 0.08 and we're just going to have 40. Now what's the small number? The smaller number is always the atomic number. The larger number is the atomic mass. The smaller number represents the amounts of P's, protons, and electrons, okay, when it's neutral. Atomic mass is actually from the P's plus the N's. So what I'm going to do first here is actually we're going to figure out how many protons we have and how many neutrons we have before we even start. So this is going to be our Bohr-Rutherford, and then this is going to represent the nucleus. And so instead of the N, or sorry, instead of the Ca here, I'm going to put P's and N's. So we know we have 20 protons. How many neutrons do we have? Well, it turns out that we're also going to have 20 because the mass equals 40. And if we have 20 P's, then what do we have to have in the N? The answer is 20. It's not always going to just be the same number. You actually have to add it up to figure it out. How many electrons do we have? Well, we have 20 electrons. How many fit in the first shell? 2. So this is my first shell. I half fill, then I pair. I like to start at the top. I have to place 20 electrons. I've placed 2 so far. So the next shell is going to be able to hold 8 because 8 plus 2 is 10. So I'm going to half fill this one. I'm trying to place 20 electrons, guys. I half fill this shell. This shell holds 8. So now I pair after I hit 4. That's 10 electrons. I have 10 more electrons to place. The next shell holds 8 as well. So it's 2, 8, 8, 8. And it keeps going after that. Like it would keep holding 8. So 2, 8, 8, 8. So far if I half fill it, now I pair. I've now placed 18 electrons. How many do I have left to place? 2. So this shell will hold 8 as well. So I put my first electron here. I can't pair at this point, guys, because it's not half full. The shell would have to have 4 before it pairs, so I put my second shell here. And this is the Bohr Rutherford for calcium. It's the hardest one that you have to do. How many valence electrons does this have? The answer is 2 valence electrons. Okay, because it's the outermost shell. And we'll talk about why that matters. That's it, folks. I hope you enjoyed the video.